In this class, I will explain another problem on projectile or horizontal plane. The problem is given like this. Find the least initial velocity with which a projectile has to be projected so that it clears a wall 4 meters height located at a distance of 5 meters and strikes the horizontal plane at a distance of 4 meters from the foot of the wall. So figure is not given here. Of course, this is a problem on a horizontal plane, projectile on a horizontal plane. Let us try to draw the figure. This is the horizontal plane on which the projectile is projected. This is y-axis. This is x-axis. So this is the point of projection. A is the point of projection. As you know, the trajectory of a projectile is a parabola. So it will be like this. So this I take as B. This distance from A to B on the horizontal plane is nothing but range. R is the range, and the maximum height reached by the projectile is h. And the velocity with which the projectile is projected, I will take it as u, and the angle of projection I will take it as alpha. So this is the diagram. So this is the parabola. Trajectory is a parabola. Now let us see what are the given data. Find the least initial velocity, that means u we have to find out, with which a projectile has to be projected so that it clears a wall 4 meters height located at a distance of 5 meters. See here. So from the point A, there is a wall here. There is a wall. This is the wall. So the height of the wall is 4 meters, given. Located at a distance of 5 meters. So the distance from A to this point, I will take as B. So this is 5 meters. So when it is projected like this, it crosses this wall and falls down at another point B, which is at a distance of 4 meters from the foot of the wall. So D is the foot of the wall. From here to here is 4 meters. So total distance is 9 meters. AB, that is range. Range value is 9 meters here. So range is equal to R is equal to 5 plus 4, 9 meters. That is known. And he has given that the projectile passes through this point P, that is the top of the wall. I will take the coordinates of this P as x comma y. Treating this as the origin, A as the origin, x will be 5 meters, y will be 4 meters. So P xy is nothing but the top of wall. Top of wall. So the coordinates will be x is equal to 5 meters. Y is equal to 4 meters. Now the question is, we have to find out the initial velocity with minimum and the least initial velocity, and also the angle of projection alpha. These two are unknown. So this is the problem. Now you know that the trajectory of the projectile is a parabola. The trajectory is a parabola. Here there are two unknowns, u and alpha are the unknowns. So at least two equations you need to solve this problem. The first equation is the trajectory equation, which you know that this you should remember. So the trajectory equation is a parabola. Y is equal to x tan alpha minus gx square by 2u square. X tan alpha minus gx square by 2 times u square into cos square alpha, or you can write it as into 1 plus tan square alpha. Because 1 by cos square alpha is secant square alpha. Secant square alpha can be written as 1 plus tan square alpha. This is one equation. Equation 1. The second equation is the range equation. Since range is known here, range R is equal to, so these two equations we have to use here. You know that it is u square sin 2 alpha by g. So u and alpha, they are the unknowns. So we have to substitute in these two equations and we have to solve to get the value of u and alpha. So u square sin 2 alpha by g is r. Now this is equation 2. So let us see how this can be solved. So once you write down these two equations, because I have used a range equation, because range is known, and since x and y are known, I have used the equation of the trajectory parabola equation. Now substituting for x and y in 1. So let us see what is the equation we are going to get. So y is 4 meters, so 4 is equal to x is 5 meters, 5 tan alpha minus g is 9.81, acceleration due to gravity, meters per second square. X square means 5 square, divided by 2 times u square, u is not known, into 1 plus tan square alpha. Okay, I will write this as 1 plus tan square alpha. I will write as this. Let us see how we can simplify this part. So this is what we get. Now just let me simplify this term. 9.81 into 25 divided by 2. It comes to 122.625. So this becomes 4 is equal to 5 tan alpha minus 122.625 divided by u square into 1 plus tan square alpha. So this I call it as equation 3. Now what I do is, I know the value of r here. R is 9 meters. That I will substitute in the second equation. Substituting for r in equation 2. So 9 is equal to u square sin 2 alpha divided by 9.81. This is what I get. Now from this u square sin 2 alpha cross multiplication will be equal to 9.81 into 9. 9.81 into 9, 88.29. So this is second equation. We get the equation 4. Now we have two equations and two unknowns. Alpha and u are the unknowns. We have two equations. We have to solve them. So let us see how we can solve those two equations. So from the second equation, from fourth equation, I can write u square as, from 4, u square is equal to 88.29 divided by sin 2 alpha. Now what I will do here is substituting for u square in the third equation. Then that means what I am doing is I am eliminating u square. Substituting for u square in equation 3, 4 is equal to 5 tan alpha minus 122.625 divided by, now I will write u square as 88.29 divided by sin 2 alpha into 1 plus, what I will do here is 1 plus tan square alpha is secant square alpha. So I can write it as 1 divided by cos square alpha. Now you can see that this equation contains only alpha, trigonometric equation. We can solve it. Let us try to simplify this. 4 is equal to 5 into, I can write it as sin alpha by cos alpha. Sin alpha by cos alpha. Minus, okay, this I will simplify this 122.625 divided by 88.29. The constant will be 1.389. 1.389. So this sin 2 alpha goes to numerator, which can be written as 2 sin alpha cos alpha divided by this cos square alpha. Now let us see how it can be simplified. 1 cos alpha gets cancels here. So what I will get now, 4 is equal to 5. Okay, I will write this as tan alpha only. There is no need to write it as sin alpha by cos alpha. You can directly retain it as tan alpha only, because RHS also you are getting tan alpha term. So 5 tan alpha minus 1.389 into 2 comes out to be 2.778. 2.778 tan alpha, because sin alpha by cos alpha will be tan alpha. So 5 minus that. So 5 minus 2.778 is 2.222 tan alpha. 222 tan alpha. So 4 is equal to 2.222 tan alpha. Therefore tan alpha is equal to 4 divided by that. So you will be getting tan alpha is equal to 4 divided by 2.222. 1.8. Tan alpha is 1.8. Therefore alpha, that is the angle of projection, tan inverse of 1.8, which is 60.95 degrees. 60.95 degrees. So this is the angle of projection with which the projectile has been thrown. So once you get alpha, by substituting either in this or in this, it is better to substitute in this. You can get the value of the least velocity u with which the projectile is projected. So substituting for alpha in equation 4. Substituting for alpha in equation 4. Substituting for alpha in equation 4. So u square will be equal to 88.29 divided by sin 2 alpha, or it is 88.29 divided by sin of 2 into 60.95 degrees. So if you simplify this, so 88.29 divided by sin of 2 into 60.95 will be equal to 103.99. Of course, that square root I have to take 103.996. So therefore, u is equal to square root of that. Square root of that will be 10.198. 10.198 meter per second. So this is the least velocity with which the projectile has to be projected with this angle, 60.95 degree angle, so that it crosses the wall of height 4 meters at a distance of 5 meters from the point of projection.